The next presentation is from team number 44, and the name of the speaker is Akshit Dhruv, and the paper title is Real-Time Sign Language Converter for Deaf and Mute.
Share.
That's fine. That is also fine.
If you will see, yes, it's fine. We can see.
Yeah.
Yes. So the
Just speak loudly so that it's further.
yeah. So the research paper is based on the real-time sign language converter for the mute and the deaf people. Next slide, please. Yes. So the abstract of the research paper is that it is aiming to develop a system which can convert the speech to text for the deaf people. And also, like suppose if the deaf people is not able to understand any language, then at that time it will convert that text to the sign language. Similarly, for the mute people, if the sign language, whatever they will try to do, that will get converted to the text and simultaneously it will get to the speech. So that we have used the technology of machine learning, AI concepts and the natural language processing, which will make the model accurate. Next slide. Introduction. According to the report of WHO, around 466 million people in the world has a problem of hearing loss. So this innovation will help not only the few people, but around 466 million people who are around the world having the hearing loss. And there is not a complete figure for the mute people, but according to the approximation, there are around 1 of every 10,000 has a problem of the mute. Next. Yes. So by the research, we have tried to cover these three main prospects. The first one is to create a feasible model, because if it is feasible, then only the people who are deaf and mute will be able to carry it. The second is the accuracy. Like if it has the higher accuracy, then only the people will able to have a trust on this model. So from our research, we have got the accuracy of 96%, which is higher than the any existing model. We have developed this model and we have made it into a single model that will reduce the complexity. Next. Literature survey. The main prospects which require is the speech enhancement. Suppose at the time we are speaking, if there is no enhancement done, then at that time there will be a problem. So the speech enhancement done by the researcher A. Narayan has done using the different layers. He has used the 9-layer prospects of CNN models, and using that they have developed the two different methods, that is the ideal binary mask system and the ideal ratio mask system. Using the ideal binary mask, it will improve the speech intelligibility, while the ideal ratio mask will help in the improvement of the quality. So we have combined these two methods and we have added our own method. So this will help it in the process. Next. The second complexity which we faced was the speech to sign language converter. As it is the complex part, like not everyone speaks uniformly. So for that, the research conducted by Stoll et al. Shows the conversion of text to speech. In his proposed method, he has used the neural machine translation methods. So we have not just used the neural machine translation method, but along with it, we have used the artificial intelligence and the whatever drawbacks which this paper had, we had tried to overcome it. Next. The flowchart of the research which we have proposed it, if the input voice will be entered, at that time if the person is deaf, then the conversion of speech to text will take place. Now, if the user is able to understand any single language, then at that time the text will get converted to the sign language. And if the person is not able to understand, then it will directly give the output. And if he is not able to understand, then it will get converted to the sign language. Similarly, for the mute people, the message will be conveyed using his sign language, and that sign language will convert it to the finally the voice. Next. So the model for the new people who are born deaf. So for them, the first of all speech, like suppose the one who is talking to him, that will get converted by before that the noise removal process will take place and the pre-processing of the audio will take place. After that, that speech will get converted to text. And for that, we have trained the neural method, neural network using the deep learning and the natural language processing. And after conversion of speech to text, we have converted the text to the sign language. And for that, we have used the machine learning to predict the answer. Model for mute people. For this, we have used the camera and the technology of a CV2 that will help to read the data, and using the Python, we will be able to detect the hand gesture. We have used the data augmentation. The main purpose of using the data augmentation is to increase the size of the data set. After that, we have used the sequential model as there are no interdependence between any layer. So we will be using the sequential model and that will help it. And after that, we have used the ADAM optimizer to get the loss value and to increase the accuracy. And for the conversion of text to speech, we have used the which is existing method of the Google Text to Speech API, which is also known as GTTS API. Next, the resultant analysis which we have conducted, the left hand side will show, right hand side will show the actual sign language, while the right hand side will show the predicted one. So you can see that we have got almost all the correct answers. Next. So like we have used the different methods and tried to achieve different types of accuracy, and we found that by increasing the data set values and the extending the training data set, we got the approximately 100% accuracy. Next. The conclusion is that this model will not just complete the requirement of the deaf and mute, but this will also bring the innovation in them. Next. References which are as per the paper. Acknowledgement. I would like to express my deep thanks to AIMV 2122 Conference Committee for giving me this opportunity. Also, I am grateful to my co-author, Dr. Santosh Bharti sir, who guided me throughout this project. Thank you.
Thank you, Akshit Dhruv. It was a nice presentation. Audience members, do you have any queries? Okay, so no queries from audience. I have a couple. So you have mentioned in one of the earlier slides that you have achieved feasibility in your work. So could you please explain that a little bit?
Yeah, so feasibility in the sense that both the model requires the conversion of speech to sign language if the person doesn't know that thing. So like if we create two different models, then that process will be long. But if we combine that both the process, then the time required for learning the process will be less. And also the feasibility contains two types, like we can do it in the two different models also, and we can combine this also.
Okay. My next question is that one of the steps that you have done is you have augmented your data.
Yes.
So how much data set you had originally used?
I had a data of around 10,000. That also I generated using the CV tools only.
Okay, and means was 10,000 not sufficient? Why did you decide to augment?
Because by using the 10,000 data, I got the accuracy of 85%. And actually, I was not satisfied with that, so I tried the data augmentation, and that helped really to increase that thing.
Okay. Okay, no more questions from my side.
Yeah, so I have two questions.
Yes.
You sorted result, right, where the sign language is converted to number.
Yes.
So there were only 10 signs
Yes.
corresponding to digits.
Yes.
I wanted to know how many different signs are there, hand signs are there, and gestures are there in actual universal sign language.
There are around, for the numbers, there are around
numbers.
Okay.
How do they communicate? There should be something more than numbers, right?
Yes, they have a predefined language, universal sign, and there are around more than 3,000 words. 3,000.
Okay.
And from that, we tried to work upon around more than 1,000.
1,000.
Yes.
So why only 1,000? Why not all?
Like we got the accuracy and we also are working on this. So just now we had a data of around 1,000 for the training purpose. So we are working on it, and as soon as we get the more data, we can work upon the next 2,000 data.
Okay, so data availability was
Very less in this field, yes.
Okay. Second question I wanted to ask is, can you please go to that slide where you explain the speech to text conversion, the model for the deaf people, I guess.
Okay.
Yeah, the previous slide. So for this, you have used the CNN, right? No?
Yes.
For this?
Yes.
For speech to text conversion, you have used
Well,
CNN.
yes.
So is it a one-dimensional CNN or two-dimensional?
So here we have used the 3 layers. The first layer is for the purpose of the first we have used the 3, out of which the 2 are for the processing one and the third one is for the output purpose.
Okay, so what data have you used for training this network?
For this there is a inbuilt data from the BBC English to sign language converter. So that permission was granted to me, and I have a permission from that.
So right now your model only works for English to other language.
Yes.
Converting it to other language.
Yes, definitely.
The input cannot be accepted from any other language.
Yes, but this has the feasibility that it has the code design. So as soon as we get the training data set for any other language, or if the requirement is for other language, then we can train the data and we can work upon it. So it will require the less time as compared to designing from the name or the basic level.
Okay, and okay, so no more question from my side.
Thank you.
Okay,